Thank you for joining the October 2020 VMware TAM customer webinar. This webinar is organized by the VMware TAM organization with the intent of providing our TAM customers the opportunity to hear great content and interact directly with great speakers that are delivering it. So please make use of the Q&A feature to ask any questions. And if your question doesn't get answered today, be sure and reach out to your TAM and ask them to follow up. Before we get into today's content, there are just a couple of announcements. Our next TAM customer webinar will be on November 12th, and we'll have the privilege of being joined by Andrew Morgan and Chris Halstead to discuss what's new with VMware Horizon. Both are experts in the EUC field, and these folks have also created several flings that they are prepared to discuss. So please join us for this session on November 12th. Your TAM should be sending you more details shortly. As I mentioned earlier, we want you to benefit from these sessions by interacting with the speakers. So if you have any questions during today's webinar, please use the Q&A feature of Zoom and we will try and address them. And lastly, this webinar is being recorded and your TAM will be able to make the recording link available to you. And then after a few months, we'll open up the recordings to anybody who subscribes to the YouTube channel. So that brings us to today's speaker and topic. Oleg is a senior solutions architect specializing in Microsoft solutions, and Sudhir is a staff solutions architect covering enterprise applications specializing in all Oracle technologies. Each of our speakers have created many blog posts and VMworld sessions that you can find that focus on best practice for a specific technology like Active Directory or Oracle RAC. But for today's session, they will focus on the 80% commonality that can be applied universally to all applications. We'll discuss topics like vNUMA, memory reservations, SCSI controllers, and the like. And with that, I'll turn it over to Oleg.
Thanks a lot. Thanks for the introduction, and thank you for joining. So let us jump right into it. We are going to discuss today what's about virtualizing business critical application on VMware Hybrid Cloud with confidence. So first thing first, right? It's a definition of business critical application, and it's a lot of things that you can bring under that umbrella. In general, what we will be talking today is more about general best practices, right? That is what we recommend you to do to ensure best performance for your application. In any case, if you will see that some particular practices, like for SAP, for Java application, has a deviation from what we're discussing here, and you are tuning it for Java application, you will need to follow your Java guide, right? But for the most of the thing, the stuff that we are discussing would apply. So then, we're going to talk first about some common pitfalls that we are observing by doing a lot of customers calls. And then I'm going to switch over to Sudhir, who will be doing a lot of discussion around optimizing some vSphere configuration. So let me start with some common pitfalls. First of all, and first thing first, when you're doing architecture of your vSphere platform, you will need to start with collecting your business requirement and defining your SLAs. And SLAs is a very important thing, right? Because basically you will need to understand what is availability, what is the desired level of availability and performance of your app. And mostly your business will be one who would need to be interviewed for that, right? Because it's a huge of difference if like 1 minute of downtime will cost you $10 or it costs you like $1 million. Right, it's a different approach. It's a different solutions that you might be building based on that. And that's why know the cost, right? Because the thing is, as mentioned, if your downtime costs you $1 million, probably you will ask your business to get another couple of servers, another Metro application for your storage, right? If it's a $10, then it probably makes no sense. And consider trade-offs, right? A lot of things that we will be discussing today, the main goal is to maintain the best performance. This best performance might cost you manageability of your VMs. It also might cause that it will take a lot of resources. But that is something that I want to stress. What we're discussing today is the main goal is to get the best performance possible. Now let us briefly talk about CPU, memory, storage, and networking, right? And Sudhir will be talking in a much more detail. First of all, know your workload, right? Especially for databases, it's a huge difference if you are using a small number of high gigahertz capable sockets or CPU, or using a multi-core, right, like 96 or 128 core system to run your application. It really depends if it's single-threaded or it could run in a parallel, what is beneficial, what is not. And remember, especially for databases, if you're migrating from a server that has like, even an old server, but having like 3.7 gigahertz capable CPU to a generic, even a new one server with having like 2.1 gigahertz, and your application is single-threaded, your new hardware would help you, right? And the next thing, count NUMA for performance. We will talk a lot about NUMA today, but the thing is, remember and make sure that you understand how NUMA works, right? And we will give to the point, we'll give you advices on that. But that is an important part of an architecture of your modern CPU. Taking into account memory, right? It's a lot of things and a lot of the questions that I got, like regarding memory right sizing. How can I do it? Is it reliable? Is it not reliable? Our general recommendation, base your sizing on the application data. And do not use vSphere active memory counters for right sizing, right? So for example, for SQL, it will be distributed management views that will give you a real insight how your SQL Server use database. And I'm sure that Sudhir can bring a lot of more Oracle examples here. And one important thing, especially for modern version applications that are capable to do in-cache operations, having more memory or adding memory might help to decrease CPU and disk usage, because it will be you, instead of actually writing to the disk and then flashing it back, we can just do all in memory, right? And that we can see sometimes that might help you to get like 30% performance more. Talking about storage, first of all, know your pattern, like read, write, what is your disk I/O, what is your throw output. And one of the key things, understand your end-to-end latency. That is the latency that is observed from your VM or from your application if it has some in-application based counter back to your storage. It wouldn't help you to see that it's like zero latency on your storage controller, or it's close to zero latency on your data store from the ESXi perspective. What is matter is what is the experience for your particular app. And the last one, and I will switch to a live portion of our deck today, is the network. And remember that distance matter, right? If you're building a high availability solution and you want to use multiple data centers, right? And you want to split, for example, SQL Server in availability groups configuration, with one node in data center 1 and second node in data center 2, right? It still needs to cross the distance. And nothing is given for free. One again, going back to the point, remember your trade-offs, right? Distance matter, and you will need to account for that. So that is a short list, but it probably covers most of the important things that we are seeing, and I just want you to get them understood, right? And now let me switch to the live portion of this deck, right? And what we are going to cover today is I'm going to take a VM and just navigate you through the process of building your VM while taking into account our best practices and see how it's fit, right? So consider to use Q&A if you have any particular question. And remember that we'll be switching to the deck just after I will finish my live demo with a lot of more details, and also we'll be sharing the deck after this presentation is done. So I just created a VM, which is called Test SQL Server. I'm sorry for having SQL servers as my specialty, right? So if you will be talking to Sudhir, it will be Oracle, right? Whatever, you can call it Test BCA, right? But let us see how it's configured. And just to confirm, you're able to see my screen, right, Andy?
Yes, we can see you.
That's better. Okay, so let us start with the CPU section first. It looks very simple, right? I just assigning number of CPUs that I want to provision to that VM. And like at least half of the persons that I talk to, they say, okay, if I ask to provide 12, I just put 12 here and I'm done, right? But what I would recommend, just let us take a look when we'll expand this session. It has at least two important settings that I want you all to understand the impact of, right? Let us start first with the first thing, CPU hot plug, right? CPU hot plug is a nice feature. When it's got enabled, I can add CPU while my VM and application are running. And if my application is able to handle hot plug of CPU, I would be able to use it, which is great, right? It's an unfortunate thing, but CPU hot plug, and just a note here, all what I'm using is a vSphere 7.0. So your environment and how you're creating VM might be different from what we have in 7.0, but the most basic practices would apply, right? So CPU hot plug, unfortunately, has some performance impact. Once you enable it, then vSphere and SCSI would basically disable all NUMA optimization for that VM. What does it mean? It means if you have a VM with 8 CPU and we can schedule them inside of one NUMA node, instead of that, we'll be exposing a uniform memory access, and SCSI would randomly schedule your CPU calls and memory blocks that are accessed by that CPU threads. What is the impact? So we have a performance study together with the performance engineering team. And the basic is, with a VM with lower CPU count, like 8 here, for example, this impact might not be seen, it's around 1%. But if we will bump this up and say we want to go with 36, right? If I want to go with 36, that is where your impact might be close to 5 to 7% of performance decrease while running your performance database testing. So if performance is your main goal, ensure that CPU hot plug is disabled. And now the next thing is a cores per socket ratio. So what I'm seeing here is I have 2 cores and then 18 sockets, right? What is interesting is that is exactly information that would be given to your VM, and that is how your application would optimize the execution based on this information. So for example, SQL Server, based on that configuration, would assume that it's running on a strange physical server having 18 physical sockets with just 2 cores. So what does it mean if I have my parallel execution plan configured to use 5 CPU threads? SQL Server would disable all level 3 CPU optimization. Why? It's because we're actually telling that we have 18 physical sockets, right? And if I have 18 physical sockets, I'm not able to share any L3 cache between them. So while configuring your cores per socket, make sure to understand your physical server architecture. So let me click cancel here, then let me go to my server. It's VMware Cloud on AWS, right? And we have 36 logical. And if I expand my CPU, I would see that I have 2 sockets and I have 18 cores per socket. What does it mean that if I go back to my test VM and I want to configure 36 CPU, in my cores per socket, I would need to do it an opposite way. I would need to go with 18 cores and then split it between 2 sockets. So as a rule of thumb, always reflect your real physical hardware configuration while doing cores per socket assignment. So ensure that you're not exposing more than 2 sockets if you're running on a 2-socket server. And if you have a 4-socket machine, ensure that you're not exposing more than 4 sockets. And one more thing, what would happen if I change it now, let us say from 36 to be 20? Interestingly enough, vSphere would change your cores per socket assignment, and not in the best way, right? So you will have 20 sockets with just 1 single core. So for that one, you still would need to revert and go to 10 and 2. What does it mean for you? Every time when you're changing number of CPU assigned, ensure to check your cores per socket ratio. If you're using an automation in PowerShell, Power CLI, you will need to specify exactly cores per socket that you want to do. Otherwise, going from 20 to 22 actually would reset all the things that we discussed, right? And one more thing to talk about CPU. While sizing your VM, make sure to understand what is shown here under the CPU section. We have 18 cores on one socket. And now let us talk a bit about NUMA. That is what Sudhir will be covering a lot of more based on the slides. But remember, we have a server with 18 cores with 2 sockets, right? So if I want to configure my VM with 20 cores, with 20 CPUs, that would mean my VM would need to be wide NUMA. Because I have only 18 physical cores on one socket, I'm not able to schedule 20, right? I would need to go to the second socket, right? So that VM would have 2 NUMA nodes. Would it be beneficial? Would it be okay? It's based on the application. You will need to test it out. Some applications are optimized for NUMA, like SQL Server. Some are not optimized, like, for example, Exchange. And you might want to compare performance of your application using 20 CPUs and 18. And with 18, you will fit to one single NUMA node. Right? And remember that starting with vSphere 6.5, vSphere nowadays is doing automatic vNUMA assignment based on the configuration of your hardware and based on the configuration of your VM, right? So vSphere now is not taking into account your cores per socket, starting with 6.5 as mentioned, right? So that is like, disregard of what you're configuring in cores per socket, you will get your vNUMA right if you're not using CPU hot plug, as it would disable your NUMA, right? But we talked a lot about CPU, right? And let me ask if it's any question.
Yeah, Oleg, okay, go right.
Yeah, go.
We have 2 questions.
Sure.
Regarding vNUMA, version 6.5 and above, doesn't VMware just choose the best performance anyhow, no matter what you put in for the values?
Correct, that's correct. So vNUMA would be done correctly, but what I am talking here is your application, like SQL Server, would actually use those settings to adjust the behavior. And if SQL Server would like to run a query in a parallel, and it will be running in 5 parallel threads, so meaning it's using 5 different cores. And I have just 2 cores on one socket. I'm not able, SQL Server would not enable level 3 cache sharing on your CPU side, right? Because SQL Server would expect that it's actually separate sockets. That is one of the important reasons for your VM hosting business critical application to reflect, still to reflect your cores per socket, even if it's right now, it's not influence your NUMA. Okay, let us switch to another question.
All right, are there plans to make the socket cap or notify you if you've configured more vCPU than the amount that's physically available?
So right now, you're able to configure it more than physically available only if hyperthreading is there, right? If hyperthreading is disabled, in that case, you would be able only to configure what you have on physical. For now, we are counting on a logical CPU. So the best thing is to check your host configuration first and then configure a socket. I haven't heard about any plan to notify that you are assigning more CPU to your VM than you have actually more than physical cores. That is something that we might consider, right? So it's a good feedback. But for now, the best thing for you is to understand your physical hardware. So check what you have and then ensure that you are taking a right decision. Okay, let us move on. I don't have a lot of time as I need to give a time to Sudhir to talk. So let me switch to memory. From memory perspective, right, you are just assigning number of gigabyte, right, that you want to give to that VM. And we have a couple of more settings. So memory hot plug. Interestingly enough, starting with 6.5, memory hot plug has no performance impact, right? So if you want to use it, you can use it. And that is different from CPU. So CPU hot plug has performance impact. Memory hot plug could be enabled. Another thing for memory, right? If you know that your environment is overcommitted, or you want to ensure for your databases best performance possible, you might think about reserving all gas memory. It has a couple of effects, right? So first of all, this memory would be physically reserved, so hosts would not be able to give it to other VMs, right? And so if your VM is just using 1 gigabyte out of this 8, still other 7 will not be used, right? That is the one. The second one is if you have vSphere HA and you have a lot of memory being reserved and one host will be out, and for some reason other hosts would not be able to have a free memory that is enough to accommodate your VM with reservation, vSphere would not start it, right? So use with caution, but reserving all gas memory, that is something that we recommend to ensure your best performance. And one good benefit of having all the memory being reserved is it will be no swap file created. So for 8 gig is actually nothing, right? But I can go as much high as 512 on this particular server, right? If I have a lot of memory in my physical server, all this memory, we need to create a swap file equal to amount of memory assigned to a VM. So for example, if on your cluster you have 16 terabyte of memory on all of your hosts, and you are not using reservations, that it will be 16 terabyte of storage that will be used by swap file. So reserving memory will also spare you some disk space, right? As mentioned, it's up to you how to decide how you want to go, but what I should say, if you're running some mission critical application in your general purpose cluster and you want to ensure that from memory perspective, they're operating fine. And by the way, having an issue with memory is probably the worst issue that you can have, right? For that one, I highly recommend you to get memory being reserved. Okay. Then let me switch to the storage part. For the storage, it looks very simple, right? I just use hard disk, and then I have my storage resources being assigned, right? It's not a lot of things to consider, but the most important one is your SCSI controller. Default SCSI controller for your Windows-based VM is LSI Logic SAS. Is it the best one? I would say in most of the cases, I would recommend to go with VMware per Virtual because it has better performance with a lower CPU consumption. What does it mean for you? You can split your disk and use VMware per Virtual for all of your controllers. And one more important thing, you can have up to 4 SCSI controller per VM. So I can add a new device and say, okay, I want to add a new SCSI controller. And then I can move the disk. Remember that new SCSI controller by default will be LSI Logic SAS for all your Windows-based VM. Change it to your VMware per Virtual, and then ensure that for your hard disk, you will also change your assignment from SCSI controller 1 to new SCSI controller. And use for your VMs having a lot of disk, we recommend to go up to a maximum of 4 controllers. You can reserve 1 for your operating system and then split your disk between 3 other controllers if needed, right? Also, one more thing, you probably noticed that on a new system, you not only have a SCSI controller, but also NVMe controller. For now, we do not recommend you to use NVMe controller for business critical application. That might change, But for now, our recommendation is to stay with SCSI and VMware Virtual. And now the last thing that I want to talk here is your network adapter, right? For your networking, make sure to check your default adapter type. It should be set to VMixNet3. When you are adding a new network adapter, right? Also, again, for Windows system, that might be different. For some old Windows, if you configured that as being, for example, Windows 2008, right? For that one, it might be that it will be E1000. E1000 is a very old driver that will be used. The driver basically 2002, so it's already like 18 years old. It's just 1 gig. You would not be able to get more than 1 gig. So make sure to use VMixNet3. And by the way, even if your VM is powered off, as for example, this one, you would not be able to change it after that. Your adapter type is hard-coded, right? So you will need to add a new one and remove an existing one. If you're using some high availability cluster configuration in your VM, make sure that such configuration are correctly applied while changing your network adapters. Okay, I have 2 minutes left. So let me switch and show also 2 more things. Guest-OS and compatibility and VMware tools. That is what you're seeing on the summary screen. Make sure that your guest-OS actually is the one that you're installing. If not, I would recommend to adjust it, because that will also influence on the version of VMware tools and some optimizations that we are doing. Your compatibility of vHardware level. We recommend you to go up to the maximum that you have, right? Because, for example, we introduced support for new Intel CPU Skylake while doing compatibility level 15. Before that, a VM running on a Skylake would not be able to take advantages of Skylake hardware advanced instruction set. And VMware tools should be installed, right? Installed, up, and up to date. That is the basic thing. And I hope that that butterfly demo gives you a better understanding of how you would configure a basic VM to host your business critical application. And now I will hand over to Sudhir. I will stop sharing, and he will go in much more details using our deck. And I will take care of your Q&A session. So I will stop share. And Sudhir, it's all yours.
Can you hear me?
Yes, we can.
Oh, okay. All right. Let me go ahead and share my screen here. And can you see my slides? Or can you see our slides?
Yeah, we see the presenter mode right now.
I'm sorry. Let me quickly switch it. All right. So good. You guys can see my slides?
Yes, we can.
All right. Thank you. All right. So yeah, so I think I'm going to skip over a couple of them, right, for the sake of time, right? And I think, Oleg, please feel free to jump in at any point of time. You've already covered the common pitfalls, so I'm not going to go over them. Oleg has gone in great depth in his demo, and he has covered the 4 tenets or the 4 quadrants of a virtual machine, the general quadrants of the virtual machine, the memory, CPU, the disk, and the network. I'll try to cover them as well here, and then we'll open them for question and answers for you guys. So I think this is pretty much, Oleg, that's your slide. So I'm going to move over this one unless you have anything in depth to talk about this, right? So essentially, when you start looking at, so Oleg did take an example of a virtual machine. He walked in through the different nuances, right, of vSocket, vCores, right, what physical NUMA is, what virtual NUMA is, what happens when you over allocate. I hope he did that. Talking about memory reservation, right, talking about should you reserve the entire virtual machine memory versus reserving what the application really requires, right? So what happens is most of these best practices, 80 to 90% of them, kind of adhere to all of the business critical application, right? So they pertain to all the business critical application. It's that 10% where we kind of deviate when you start talking about the SQLs or the Oracles or the Exchange, right? Or the, or the other application like Java, right? For example, if you look at Oleg's point of view, that would be if a virtual machine has 256 gig of RAM, right? And if you wish to reserve it, you should reserve the entire virtual machine memory, right? But if you look from an Oracle standpoint, right, what the guidance that I give is, it's slightly different than what Oleg gives, and that is just reserve what the database really requires. And what the database really requires is the active memory that the database requires. And when I use the word active memory, it's not the active memory word that you use in the VMware line. That's not the parlance, right? So the word here is the memory that Oracle requires, which is essentially a system global area, the SGA plus the PGA, right? But those are some of the nuances where we deviate, but most of these best practices, they pertain to all business critical applications. Right, so essentially we start with the physical hardware. We'll go into some of the best practices as to what should you do and what should you not do, what should you avoid, what should you be cognizant about, right? So essentially when we start talking about recommendations, right, here's the one-liner, right? You can choose not to put any of these recommendations and yet stuff will work. But the real question that one should ask themselves is, does it really work as per my desires? Does it really work as per what I think the application should do? And that's where these best practice recommendation comes very handy, right? And then we'll move into a bit of an ESXi, best recommendation of best practices as of what are the power policy that we talk about, the vMotion port groups, virtual machine. Oleg spoke in depth about it. I'll touch a bit on that as well, and guest operating system and so on and so forth. Right. So from a power management perspective, right, when you start looking at an ESXi server, and again, right, what happens is, there is no real answer here, right? I mean, there are two ends of a spectrum. So typically when we start talking to customers, right, I mean, you have two kinds of cap, if I can put it that way, right? You have the consolidation cap, and then you have the conservative cap, right? So for general purpose clusters, right, essentially where you're hosting your dev, your test, your non-prod, right, whether that's your staging, right, or pre-prod, it's fine, to kind of not do some of these best practices. But when it comes to business critical production clusters, right, what we recommend, throw away your consolidation cap, put on your conservative cap, right? The name of the game here is not to see how much juice you can squeeze out of the lemon. The name of the game is to make sure that you're able to sustain the workload and yet meet all of the SLAs, right? Make sure that you're able to meet the RTO and the RPO, right? And that's where you see some of these best practices come into being. For example, right, change the BIOS power setting to OS control. You want that BIOS power on the ESXi server to be set to OS control, right? The other recommendation that we say is set the power management policy for the ESXi servers to high performance. Why? Because you want the ESXi server to do what it is born and bred to do, right? Run full clock speed, run on rocket fuel for those business critical applications to make sure that you're able to finish your daily jobs or your nightly jobs within that window, right? Finish your backups within the window, so that these jobs don't overflow outside the window, right? The other recommendation that we make here is, make sure that you enable turbo boost or whatever is equivalent to turbo boost in your particular hardware. And last but not the least, right, make sure that you disable all of the C states, the C1E halt states. For the very reason you don't want the server to go on a sleep mode, right, and then get awakened, and then now you're wasting cycles in doing that, where your application, be that SQL or be that SAP or be that Oracle or be that Java, is not suffering for lack of physical CPUs or lack of cycles. Let me put it that way. So Oleg did speak about the virtual machine, the CPU configuration, right, the cores per socket, and there was a comment about what happens on 6.5. So starting 6.5, and we don't have to go very deep into that, right? Oleg already covered it. Starting 6.5, right, what happened was we delineated, right, or we uncoupled, or we decoupled, right, the dependency between cores and sockets. We essentially said, what, the ESXi NUMA scheduler is so intelligent, has become so refined, right, so sophisticated that even if one were to misconfigure, right, the virtual machine settings as based on the number of vSocket or vCores, right, we will make sure that we set the correct physical NUMA topology, right, the underlying physical NUMA topology for the customer or for the virtual machine. So that's why we decoupled the dependency between the number of cores and number of sockets. But then again, right, that doesn't mean the tenets of setting correct NUMA topology goes out of the window. essentially the recommendation that we have is stay within a NUMA node if you can, right? So for example, if you have a server which is 2-socket 10 cores each, right? So essentially you have 2 NUMA nodes, right? Each NUMA node 0, NUMA node 1 has 10 cores each, and then those cores are hyper-threaded, right? So the question becomes, should I hyper-thread or should I not hyper-thread? And the answer is absolutely you should, right? Because many customers, what happens is, Oleg and I, we're not only part of pre-sales, right? We also get pulled into escalation. We also get pulled into post-sales, right? And we both are PSO, ex-PSOs, right? When we walk into a customer, shop, essentially we see hyper-threading is turned off in the BIOS, and the very first question is why? Why did we turn hyper-threading off in the BIOS? There's no need to do that, right? So our recommendation is leave hyper-threading alone, right? Let it be enabled in the BIOS, right? But keep one thing in mind, hyper-threading does not double the performance. Remember, hyper-threading only boosts, right, the performance by 20 to 24%. This is essentially done by our performance group. They were able to find that out. So that hyper-threading then is critical come that rainy day when you need those extra cycles. So what we recommend, when you size your virtual machine vCPUs, size it for the number of physical cores, right? Size it for the number of physical cores. Make sure that the vCPUs are multiples of physical cores, right? Not the hyper-thread. So for example, if it's 2-socket 10 cores, if I have to do it, it'll be 5, 10, 15, 20, right? It wouldn't be 1, 3, 5, 7, 9 for a sole and a simple reason. If one were to come up with odd number of vCPUs in this configuration, right, you will have what's called the NUMA imbalance, and that's the last thing that you want, especially in the production environment, right? And the way that you are able to find out, if you go to ESXi, run ESX top, right, and your keys are MFGV, right? When you do that, you will see the NH migration. There's a column called NH migration, NUMA home migration. That will switch. That will keep increasing. It'll switch between 0 and 1, 0 and 1. Then you know that you have an underlying issue here with one of your virtual machine or probably with more of your virtual machines, right? Again, so the name of the game, stay within one NUMA node and check the configuration. Now, what happens is, typically if you look at databases, Oracle databases, SQL databases, they are wide. They are big, they are fat, right? They typically tend to go over or they tend to go beyond the NUMA node. So hence they are called a byte VM, right? So is that a best practice? It really depends, right? I mean, our recommendation is to stay within a NUMA node, but if we have to go across, that doesn't mean something is bad. For example, if I have a virtual machine, in this case, right, there's 40 vCPUs. So I have 20 threads on one, right? And I have 20 threads on the other NUMA node, right? Is that a good thing or a bad thing? So the way that you find out if it's a good thing or a bad thing is run the workload. There is no better test than running the workload. So test number 1 would be stay within a NUMA node, right? So in this case, you have 2-socket 10 cores, which is 20 vCPUs. My bad, that was 20 vCPUs. Stay within a NUMA node, run the test. Capture your statistics. So whether that's the SQL Server, DMV, and I'm not a SQL Server guy, so Oleg knows what DMV stands for, or if it's the Oracle AWR, or if it's the Oracle $Vs or the $X I would capture the statistics. Next, what I would do is I would go across the NUMA node, right? And then I would see, right? Then I would see as to what is the workload. And then I would capture the 2 workloads. And then based on that, right? Based on that, what I would do is then I would determine whether I should go with a white VM or I should not go with a white VM. But that would be the way that I would go, right? Now, moving on to the second thing, right? We spoke about CPU hot plug. Well, there's a pros and cons to every approach here, right? The pros to this approach is, well, you are able to add CPU on the fly, so which means I'm able to scale up, I'm able to scale out, right, on a server level. The cons to that, NUMA is disabled. The virtual NUMA is disabled. So if you have an application which is NUMA aware, right, you definitely don't want to have the CPU hot plug turned on, right? And I don't know how many people are Oracle here or people running Oracle in their shop, but one might just stand up and say, but if you look at the Oracle best practices guide, our recommendation is, right, to essentially turn off NUMA, right? Turn off NUMA because Oracle is not NUMA aware. Even if Oracle is NUMA aware, the metaling note essentially says turn the NUMA off or use it very wisely after testing it, right? Here's the thing. The operating system still has to be NUMA aware because it has to make sure that it replaces the thread accordingly based on the physical NUMA topology. So our recommendation is please don't turn NUMA off in the BIOS, right? There is no point in buying a NUMA server and turning that into a UMA, right? There's no point in doing that. So you might as well go buy a UMA server, which if and which is available in the market today, right? So our recommendation, make sure that NUMA is enabled all the way to the application. For SQL Server, it's NUMA aware. For Oracle, gotta take it with a pinch of salt. Make sure that you enable NUMA, run the workload, capture statistics, turn NUMA off, run the workload, capture statistics. right? So some of the customer workloads I've seen so far, NUMA works very fine, right? I mean, with their workload. For some of the customer workloads I've seen, NUMA actually, it actually gives a performance, is detrimental to the performance, right? So again, it depends. Your mileage may vary. So that's why if you look at recommendation, we say, make sure that, you turn off NUMA or you turn on NUMA, right? Capture the workload, right? Run the workload, capture the statistics, compare it, make sure that you pad for capacity planning or forecasting, and then decide whether you want to NUMA or not, right? And I think there was a question here which says, why do you recommend CPU hot plug disable? That was for the very same reason why I explained that, right? The third thing is CPU affinity, right? I mean, the only case that I see in the Oracle land, and Oleg, feel free to chime in from a SQL perspective, right? Where I see the CPU affinity being used is for Oracle licensing, where you wish to use a certain number of cores in a certain number of sockets in a particular server and only wish to license Oracle for those number of cores. That's where I see, right, the CPU affinity comment being. Apart from that, I don't see any real use case for CPU affinity, right? Or if you are in the benchmarking process, where essentially you want to make sure that your threads don't move around, that you focus on the number of cores, and you want to see how well you perform, right, on that particular piece of hardware, there I can see the CPU affinity coming in play. But apart from that, I don't see real use for CPU affinity here. Moving on to CPU reservations, yes, that might be used in overcommitted environment, but remember I just mentioned a couple of minutes ago, right? When you talk about business critical application production environments, right, the very notion of consolidation should actually go out of the window, right? It's all about conservativeness, right? When you talk about databases, it's all conservativeness, paranoidness. It's all about paranoid. It's all being sure that they are able to guarantee the consistency and the concurrency. So hence, we really don't encourage people, right, to go with CPU reservations here, right? That's a different topic when we come to memory, when you talk about memory reservation, right? So we spoke about vNUMA, so I'm going to move on here. And what has happened? Yeah, that's the NUMA diagram of the NUMA, right? Okay, so more on NUMA, right? Essentially, the virtual NUMA, the vNUMA, that is not exposed for any virtual machines having less than 9. You can still, trigger the NUMA, which is vCPU.NUMA.min, right? If you're able to set that parameter to less than 9, yes, you can trigger it out by default, right? If it is less than 9, it doesn't trigger it by default, right? And then we spoke about the fact that vNUMA is not exposed to any virtual machine having less vCPUs than the size of vNUMA for a host, right? And of course, I also touched about the fact that if you have CPU hot add feature, your virtual NUMA is not exposed. There was a discussion as to, do you really need CPU hot add? I mean, you would do that for dev and test environment, pretty much not for production environments. And there's also a nice article written either by Mark Akmatuk or Todd Muirhead, right? And it's there in the one-stop shop link that's there in this resource section that speaks about the performance degradation when you have the CPU hot add feature on, right? And of course, vNUMA is not exposed if the virtual hardware is 8 or below version. Right. And how do I check the NUMA topology, right? You could on ESXi run these commands, the ESX CLI hardware memory get grep for NUMA, schedule stats minus P and CPUs, or you can go, if you wish to cheat, you can even go on to the operating system, right? So for, I'm more of a Linux guy, right? And if you go into the operating system, not on the ESS level, but in the guest operating system, if you run NUMA CTL minus hardware and NUMA CTL minus show, you can see what NUMA topology is now, exhibited or enabled on the guest operating system side, right? More so from a virtual machine perspective, if that's the command you run, you would know what is the NUMA topology that ESXi presents to the virtual machine, right? So again, just to reiterate, right, it's very important to make sure that you have correct NUMA configuration, you're right, regardless of which command you use, regardless of which method you use, because it will affect the performance very drastically, right? There has been many instances where we have seen performance really go down a pipe, right? Because somebody did not take cognizance of the fact that the server was NUMA and misconfigure the number of vCPUs. So remember, right, let's not be generous and over-allocate the number of vCPUs to a virtual machine just because the virtual machine needs it, because remember, ESXi requires cycle to allocate and deallocate vCPUs. So let's not under-allocate, let's not over-allocate. Let's make sure that we allocate the number of vCPUs to an ESXi server correctly. And how do you do that? When you do right sizing, right? When you come off a physical platform to a virtual platform, right, you have to do right sizing, whether that's Solaris, AIX, HP, UX, more so in the Oracle land, or whether you're coming off on physical x86 to a virtual x86. The right sizing is the key, is the ask of the day here. All right, so changing gears and moving to the memory aspect of this discussion here, right? So yeah, and I'm sorry, Brian, how are we doing for time here? Do we have time?
Yeah, we're good. You can go until what would be 12:30 Eastern if you want, or we've got at least 10 minutes, probably closer to 40 minutes if you want them. Got it. Okay. All right. Thank you. All right. Thanks for that. So yeah, from a memory perspective, I mean, already Oleg spoke about the fact, right, that you want to make sure that you avoid any kind of overcommitment of memory at the ESXi host level, right, and that you want to check the hardware P NUMA memory allocation. I think key thing to keep in mind, the memory hot plug has no performance impact, right? And I spoke about those nuances that set SQL and Oracle aside, right? Again, from a memory reservation perspective, if you do have the memory, so for example, let me give you, right? There are some shops that run SAP on Oracle, right? And when I speak to those customers, they basically say, I have oodles and oodles and oodles of memory, right? So I really don't want to go through the whole exercise of figuring out what the SGA, what the PGA is for the database. I might as well reserve the entire virtual machine, right? Is that okay? That's fine. If you have the luxury of spending memory or throwing memory at the virtual machine, sure, you can do it. But if you don't, right, what is the minimum that you need to reserve? That's the SGA plus PGA for Oracle, right? From a SQL Server perspective, right, we have memory reservation, set it to equal to the provision memory. And again, Oleg, at any point of time, please jump in, right? And again, when you start looking at these, what we recommend is, start looking at the native performance metrics. If you want to look at the native performance metrics, use the database, the metrics that is available with that flavor of database. So if it's Oracle, look at the AWR, look at the ADDM, right? Look at what the diagnostic, the monitor, what are the recommendations that ADDM gives you, right? Look at the $V views. That is basically your dynamic views that tells you what's happening at the database, or why is my job waiting? Because remember, everything at some point of time will wait for something. Okay, that's how it works in today's world, right? So if you look at jobs, or if you look at sessions, or if you look at SQL statements, right, they will wait for some resource or the other, and based on that, that's how you do your tuning based on the wait events, right? And a similar concept, I assume, is there for SQL Server as per se as well, and that is using your SQL Server DMVs. So moving to a topic which basically, this piques the interest of many people, right? And many customers, when we speak to them, they essentially say, oh, should I go VMFS or should I go the RDM route, right? So, if you had asked this question probably 10 years before, right? Probably 10 years before, we would have said, yes, absolutely RDM. Because yes, I completely agree with you. There is a performance difference, or there was a performance difference. Let me put it that way, right? But now, when you're talking about the recent releases of ESXi, whether it's 6.0, 6.5, 6.7, 7.0, 7.0, U1, right? That performance difference has become very marginal, right? There are certain use cases when one has to go, or one has to determine whether one requires a VMFS or one requires RDM. The use cases for RDM is when you cannot live without your SAN backup and replication technology, right? Or when you need it for Microsoft Quorum, right? Whenever you need that, or the shared disk failover clustering. And again, I'm not a Microsoft Core guy, right? That's where RDM comes into picture. Otherwise, you don't need RDM, right? Just think of it, right? I mean, a couple of customers I spoke to, they said, oh, you know what? We are using physical LUNs for our Oracle rack, or let's say for our Oracle databases. Now, when I want to migrate my Oracle environment to a virtualized, when I want to move my Oracle database to a virtualized environment, I would like to go with RDM. Just think of it, right? You only have 512 LUNs. That's the limit that you have, the SCSI limit that you have, right? If you were to come up with these little islands of 1 gigabyte, 2 gigabyte, 1 terabyte, 2 terabyte for your Oracle databases, there is only so much you can provision for your Oracle databases across the landscape. And then you run out of LUN limit. Well, what then happens? Well, you have to go and get another cluster. You have to provision another cluster. So again, you don't really need an RDM, right? If you look at all the guidances, if you look at all the guides that we have written so far, everything is based on VMDK, because there are a lot of throttles, levers, right? There are a lot of controls that we give that you can use, that you can use on VMDKs, on VMFS file system, right? But again, if I understand, what I would recommend is, if you're still not convinced, right, maybe you guys should go back and run a POC and see if that really helps you, and then look at the entire gamut, right? Look at what
I mean, it's not just about performance, right? About the features, about your flexibility, right? What you can or what you cannot do with RDM versus BMFS. But again, this is an ongoing discussion, right? A very interesting one. All right. Moving on to vSAN, I am sure everybody knows what VMware vSAN is. That's our hyperconverged infrastructure offering that we have, and now it's become, it's come to the point where it's very sophisticated, it's very honed, right, and it's got a lot of capabilities, a lot of features up here, right. And then what we recommend is absolutely, I mean, I really don't know how many customers are using hybrid. Once you have the all-flash vSAN, right, but with the advent of NVMe drives, right, the vSAN infrastructure becomes more and more performant and more, it's more and more accelerated, right? Okay, so when you start looking at, the different RAID levels, right? There are three different RAID levels, right? You have RAID 1, you have RAID 5, you have RAID 6, right? And essentially, when you're looking for more capacity, right, that's where you go towards the RAID 5, the RAID 6. If you're looking towards performance, you have to go with RAID 1, right? But then the first question that, when I speak to, Oracle guys who are considering vSAN, they say, hey, everything is performant in this database. Why don't I put everything on RAID 1, right? Think of it. You start putting everything on RAID 1, there is no capacity savings here, right? It's more of performance. But the question one should ask themselves is the entire data set of the database, is that performant? Does that require, the high performance drive? I mean, this goes back to the same concept of storage tiering, where essentially we just say the entire database required, right, all flash drives, right? No, it really does not, because if you look at the active data set of a database, right, typically 20 to 30% are active, right? The other part of the database, they would typically be warm, and some part of the database would be cold, right? So depends on what that data set is doing in that database is where I would go and say use either RAID 1 or RAID 5. But typically we have seen for RAID 1, please put your redo log files on RAID 1 for performance, right? RAID 5 and RAID 6 are typically good for databases, but again, your mileage may vary. So what we recommend, please test it out, right? And there's this whole concept of OSR, or object space reservation, right? Essentially, by setting object space reservation, you're saying, you're declaring your intent and saying, I need this much amount of space for my database or for my application on vSAN, right? And there used to be, there was a requirement, right, before vSAN 6.7p0, or if you were deploying your databases on VMC, SDDC 1.8 version 2, where the shared devices, which is required for an Oracle rack, using the multi-writer, that required OSR space 100%. It's not anymore, right? So if you guys are planning to run Oracle rack on vSAN, starting 6.7p01 or on VMC, the VMware Cloud on AWS, absolutely, you do not require your shared devices using the multi-writer flag to be eager 0 thick. You do not require that to be OSR 100%, right? And the bullet point after that, which basically says use multiple VMDK per workload attached to different PV SCSI controller. That's of utmost importance. And I still see people, right, because I said, Oleg and I, we are XPSO, right? We also get involved with customer, right? Especially when we are tri-edging or troubleshooting, or when we have these pre-sales calls. And the one thing that I've noticed is you'll have one poor virtual machine with one poor PV SCSI controller and many multiple VMDKs hanging off that. And my question is why? Why would you want to do it that way? See, for a simple and sole reason, right? Just as in the physical LAN, right, one has queues. You have queues. In fact, there are 24 to 32 different queues in the entire stack, right? You have queues at the LAN level. You have queue at the physical HBA level. Similarly, you have queue at the VMDK level, and you have queues on the PV SCSI level, right? And those are the queues that you can't escape from. So when you have the queues on all these levels, right, you want to make sure that you use multiple PV SCSI controllers and multiple VMDKs per PV SCSI controllers in order to make sure you have load balancing, you have fairness, you have queue depth, right? So for all those reasons, we recommend make sure that you have different SCSI controllers and make sure that you, if not stripe, at least distribute your VMDK among different SCSI controllers, right? See, that concept is not different than what one would do in a physical LAN. I mean, you definitely will not have, one LAN, and on one LAN, you wouldn't have, like, say, all the databases on one LAN, correct? You would make sure that you have multiple HBAs and multiple HBAs and multiple HBA ports. You have different LANs assigned to different HBA ports, right? Fan in, fan out ratio. The same concept applies here as well, right? Last but not the least, please make sure that the vSAN network is robust, right, and at least 10 gigabit. For the sole reason the vSAN traffic travels over that, right? You want to make sure, right, because it's a different architecture than what you have with a traditional SAN or a NAS, right? You want to make sure that your vSAN network is redundant, it is high performant, at least 10 gigabit. But then what happens is the best way you can test it out is run your workload, look at the different metrics that vCenter provides you, look at the different metrics that vSAN provides you, and then make a determination as to if this is good or you would have to up the ante. Shifting gears, right, from vSAN over to storage best practices, right? Partition alignment, that is very critical. Whether the partition alignment happens at an ESXi level or whether that happens on a guest operating system level, this is of utmost importance, because remember, if you don't have partition alignment, multiple or one physical IO will transcend as multiple physical IOs, whether it's read or whether it's write. So we want to make sure the partition alignment is done, right? Starting RHEL 6, starting RHEL 7, we don't have to worry, right? I'm more of a Linux guy, like I said before. The guest operating system will partition it very beautifully, the operating system and any other drives, right, on a 1 megabyte partition, right? Typically what we say is, if you want to do this correctly, the partitioning offset should be what you should be asking your storage guy. So basically ask the storage vendor as to what is your chunk size, or what should be the partitioning offset I should use in my VMDKs, and that is what you should be using, right, as per partition alignment. The second thing is eager zero thick versus eager zero, whether thin or whether it's lazy zero. It all goes back to what is the application and what is the nature of the application. I mean, typically if you look at, supercritical applications, right, especially on SAN, we say, you know what, make sure that you have the VMDK set to eager zero thick, especially for Oracle RAC on SAN. On traditional SAN, the requirement is still there, right? We're using multi-data flag, eager zero thick. You don't have that requirement on vSAN. But again, certain operations like creating table spaces, creating data files, doing data loads, right? It actually helps you if you have those VMDKs as eager zero thick, because remember, right? You don't want to take a penalty on the first write, right? And that first write penalty actually happens, right, when you do any of these operations, right? So we spoke about vSCSI virtual controller, right, up to 4 per virtual machines, and the fact that you're able to go up at 64 VMDKs per vSCSI controller. So that gives you a total of 256 VMDKs per virtual machine. Every VMDK can go to a max of 62 terabytes. You guys can do the math. So that's the amount of memory, or that's the amount of storage that a virtual machine can address, right? And then yeah, absolutely. Snapshots. There's a conversation here about pros and cons of snapshot. Snapshot is something that you want to use if you have to go back in time, right? If let's say if you're doing some kind of patching operation, but that shouldn't be used, or that shouldn't be taken as a form of backup, right? Because remember, every time you delete a snapshot, right, there is a brief stun moment, and there is a KB article that talks about there's a brief stun moment where those snapshot deltas have to be coalesced back to the main, right? And then at that point of time, if you guys are running a big load, right, you might have some kind of performance, degradation. So what we recommend is, if you really have to do snapshots, do that. But if you have to coalesce it or delete it, do that during a quiet time, right? Do that when there is no job running, right? So spoke about that a bit. Yep. With the networking recommendations, right, we recommend, as you would do in the physical LAN, right, separate the traffic between different port groups. For example, if I were to talk about Oracle RAC, right, the fact that you don't want to put your Oracle RAC private interconnect traffic on a vMotion, along with the backup, along with the management, along with the public, you don't want the entire zoo flowing through the pipe, right? Because what happens, bad things will happen to you, right? So you want to make sure that you separate the traffic for different applications or for different application needs, right? If you have the ability to do that. If not, use quality of service. At least make sure that, for example, if I'm using Oracle RAC, make sure the quality of service is set for that particular traffic, so that gets priority, right? And if you have a 10 gigabit or more, right, jumbo frame. Jumbo frames helps you not only for private rack interconnect, also helps you for vMotion, also helps you for backup traffic, right? So these are accelerators that are provided by the vendors. So please be cognizant of that and use it, right? Of course, VMX Net3. So use case for VMX Net3 could be the private rack interconnect, or could be even your backup NIC or the vNIC, right? So you're able to accelerate it the same way as vSCSI is. These are drivers, right, which use rocket fuel to accelerate your workload performance. Again, make sure that you upgrade your VMware tools. With Linux, you have your open VM, so that's great. Every time you create a virtual machine, right, when you do the yum open VM, right, you make sure that you have the latest and the greatest here. Make sure that you upgrade the virtual machine compatibility to match your ESXi server. And I don't know if you're talking about the templates in the other slide, but the thing is, probably we should have added this one point here, right? Golden templates. That is of utmost criticality. That's very important, right? To make sure that you have a golden template. One would ask the question, why do I care about templates? No, it's very important. But what happens is when you create a template, right? When you put in all the best practices, right? When you put in all of the things that you require for a virtual machine, it is so easy then cloning or deploying a virtual machine from this template and distributing the copies to your people, right? So that way, if you have to go back and make a change, you go back to the source, which is the template, and make that change. So if you look at any other best practices guide, right, for any other business critical application, the first line would say, make sure that you use a template for the golden operating system, right? Make sure you do that. In fact, the way I do it when I have to deploy anything is I have a template. I make sure I put everything in there. I even stage my binaries, right? I make sure that I have Oracle ASM library installed in that. I stage my binaries. I make sure I have the the latest and the greatest security patches. My grub is completely updated so that when I deploy a virtual machine from that template, I know I am getting the best, and then I don't have to go and tweak this or tweak that, right? So again, these are recommendations. These are not set in stone. This will make sure that your life is easy, right? Right. Some resources that Oleg and I put together, right? I mean, performance application blog is at the top. You have the Oracle on VMware best practices guide, and the one-stop shop essentially is a collection of anything and everything that has been created on Oracle on VMware, whether that's licensing, whether that's Oracle on vSAN, Oracle on vWall, Oracle on VMware Cloud on AWS, whether that's KB articles, whether that's documentation, whether that's with persistent memory or with RDMA drivers. Same thing with SQL Server. You have SQL Server on vSphere resources in the bottom that Oleg is in charge of. He maintains that, and the VMware SQL Server best practices guide that Oleg is the author of, right? But I think we are at the end of the slide here. So I don't know, Brian, back to you. Maybe do we have to? We can probably open this up for some question and answers, or however you guys want to do it.
Yeah, no, thanks, Sudhir. Sorry. Looking at the Q&A, it looks like Oleg's been taking care of things that have come in and answered those. So we don't have any questions at the moment. We'll give it just a minute here. Just a reminder, if you do have a question, feel free to type it in the Q&A and we'll try and handle it live. And if you think of something after the fact, be sure to reach out to your TAM and they can follow up offline. All right, well, still nothing in Q&A. So Oleg, Sudhir, very useful session. Really appreciate you guys taking the time to do this. Actually, we did have, there's a comment in Q&A that you're invited to someone's data center and beer is on them. So that's the one comment right now. But as we mentioned,
once you would be allowed to travel, right?
Yeah. So rain check.
Yeah, it would have to be virtual beer. Right? It would have to be virtual beer for now. Be beer. Yeah, be beer for now.
You should be seeing a way to get a bottle of beer out of your laptop.
The Zoom feature request in, right? So as we mentioned at the beginning, the presentation was recorded. Your TAM will be able to make that recording available to you. And please join us again next month when we'll be taking a look at what's new with Horizon. And we look forward to seeing you for that on November 12th. Thanks.
Thank you.